Okay, this is section 8.7, parallel lines and proportional parts. So what you're going to do is use proportions to solve for missing parts of triangles. And we're also going to look at triangles with parallel lines. You can set up your proportions in different ways. So first, let's look at example this first example. So if we start with CB, and I'll highlight this as we go to show you what ways you can set up your proportion. So I'm looking at this first proportion here. If we have CB first over CA, which is the whole length, you could set it up on the other side, CD over, and it would be the whole length on the other side, so CE. That's one way to set up a proportion when you have these parallel lines. So see these lines here that are parallel? If the lines are parallel, you can set up a proportion just like this. That's one way. Another way to set up the proportion could be CB over CD equals CA, the whole thing, over CE. You could also do BA, the smaller piece, over CA, the whole thing, equals DE over CE, the whole. Okay, another way, you could do CB over BA equals CD over DE. I personally like this one because it's the easiest. You don't have to find the total amount like you do on the top three proportions, but I would just choose one that you like and stick with it, and that's the way you should set up your proportions. Okay, this next one is CB over CD equals something over DE. So the missing piece would be BA. And then the last one would be BA over DE equals CA, the whole thing, over CE. So those are 6 different ways you could set up the proportion. And like I said, the orange one, that's my favorite because you don't have to find the total. But you can use any of these that you want. Okay, on example 1, we're trying to determine if it's true or false the way the proportions are set up. So on part A, we have FA over HA equals FB over TB. That's set up the same, so that is true. Okay, part B, let's see if that is true or false. FT over FH equals FB over FA. Again, that's set up the same, so that one is true. Okay, part C, FH over FT equals HA over TB. Set up the same, so that's true. Part D, FA over FH equals FT over TB. See how when I colored and shaded the parts that it was telling us, they're not the same parts, so that's not going to work. So this one would be false. The other 3 would work. Okay, now let's use our knowledge to solve this problem. Okay, so example 2. I just showed you multiple ways that you could set up your proportion, but remember my favorite was setting up this over this equals this over this. So that's how I'm going to set up my proportion. So I'm going to say x over 1 equals 8 over 2. Cross multiply. So I have 2x equals 8. Divide both sides by 2. And x equals 4. So this length would be 4. You could also think of the scale factor. 8 divided by 2 is 4. 4 divided by 4 is 1. So the scale factor would be 4 if you're comparing them. Okay, example 3. Now this time your parallel lines are located here. So I'm going to set up my proportion with this length here over this length equals this length over this length. So when I set that up, it's going to be 5 plus x over 3 equals 8 plus x over 4. When you cross multiply here, you have to distribute. So I'm going to write that out. 4 open parentheses 5 plus x equals 3 open parentheses 8 plus x. So we have 20 plus 4x equals 24 plus 3x. I'm going to subtract 3x from both sides, and I'll go ahead and subtract 20 from both sides. So that will give me x equals 4. So we found the value of x, that's all we had to do. Okay, there's another theorem here. It says, if a line intersects two sides of a triangle and separates the sides into corresponding segments of proportional lengths, then the line is parallel to the third side. So this time we're working backwards. We're going to label all the side lengths that are given. So it says in triangle EFG, EG is 15. So this whole length is 15. EH is 5. And it says LG is twice FL. Well, we don't know actual measures, so I'm just going to use variables. So I can say FL, we just call that X. LG is twice that, so I'll call LG 2X. Okay, I'm going to set up the proportion like I normally do. So I'm going to take 15 and subtract 5 to get HG, and that length would be 10. So now when I set up my proportion, I can say 5 over 10 equals X over 2X. If these are equal when we cross multiply, then we know that the lines are parallel for sure. So if we cross multiply, we get 10x equals 10x. So yes, these are equal. So that means these lines are parallel. So we can say yes. If they weren't equal to each other, then we would say no, they're not parallel. Okay, example 5. Again, we're doing the same thing. So AC this time is 30. AE is 22. AD is 10, so that means that DC is 20. And EB is x plus 4. So I'm going to set up my proportion. 10 over 20 equals 22 over x plus 4. So let's cross multiply and divide. So we have 10 times x plus 4 equals 22 times 20 is 440. So then we distribute, we get 10x plus 40 equals 440. Subtract 40 from both sides. 10x equals 400. Divide by 10, and x equals 40. So on this one we get an actual value, so we need to determine still if these sides are proportional. If 10 goes to 20, that means it's doubling. So we need to see if it's the same on the other side. So if we plug 40 in here, that would make EB 44. And is that double 22? Yes. So these sides are proportional. So that means DE is parallel to, that's supposed to be CB. So yes, these are parallel. Okay, we have another theorem. This theorem says if you have a segment whose endpoints are the midpoints of two sides of a triangle, is parallel to the third side of the triangle, and its length is half of the length of the third side. Okay, that's a lot, but ultimately, if these pieces are congruent and these pieces are congruent, then that means this length here, the 4x minus 5, is half the measure of the x plus 11. So in order to find x, we're going to have to double this length in order to set it equal to the top length. So I'm going to take 2 times 4x minus 5, and then I can set it equal to the x plus 11. So that would give me 8x minus 10 equals x plus 11. So subtract x from both sides, add 10 to both sides. That will give me 7x equals 21. Divide by 7, and x equals 3. Now for y, we already know over here those segments are congruent to each other. So we can just take 4y plus 6 and set it equal to 2y plus 18. And then I'll just subtract 2y from both sides, subtract 6 from both sides. So 2y equals 12, divide by 2, and y equals 6. Okay, there's a lot of theorems in this lesson. This next one says, if 3 or more parallel lines intersect 2 transversals, and remember, a transversal is just a line, like this line and this line, that cut through 2 or more parallel lines. So this theorem says that if you have 3 or more parallel lines, then they are going to cut off the transversals proportionally. So we could set up proportions this way too. We could say PQ to QR equals DE to EF. That's one way. Or we could do PQ to DE equals QR to, again, EF. So you could set up the proportion either way. So let's check and see if these are proportional or not. Part A says A over B equals C over D. Yes, that's set up proportionally. Part B says A over C equals C over D. We didn't even get B in the mix, so this is definitely a false. That can't work. Part C says A over D equals C over B. You can't crisscross, so that's a false also. You have to stay on the same side, or you can cross over to the same length. So we could say A over C, but we can't say A over D and crisscross over. Okay, or we could do, let's see if this one is true or false. B over C equals A over D. See how that crisscrossed again? So that means this is also a false. That won't work. Can't crisscross it. Okay, so number 8, example 8 says find the value of x. So just set up the proportion. Literally as it's written, I could just put bars here and put it equal to, and that could be my proportion. And that's what I like to do. It's the easiest way. So I can say 5 over 7 equals x over 9. So that would be 7x equals 45. Divide by 7. So that makes x 6.4. Okay, we have 2 more examples. Example 9, we have to look for x and y. So first I'm just going to focus on x. So I'm going to take x over 3 equals x plus 3 over 4. And that's how I'm going to set up the proportion for x. So now I'll cross multiply and divide. So I have 4x equals, make sure you distribute here, 3 times x plus 3. So that will give me 4x equals 3x plus 9. Subtract 3x from both sides. So that means x equals 9. For y, I'll do the same thing. I'll take y and I'll put it over 3, and then I'll do 2y minus 5 over 4. So I have y over 3 equals 2y minus 5 over 4. Cross multiply, 4y equals, make sure you distribute, 3 times 2y minus 5. So 4y equals 6y minus 15. I'm going to subtract 6y from both sides. So I get a negative 2y equals a negative 15. Divide both sides by negative 2, and y will be positive 7.5. So I had to use 2 proportions because we were looking for 2 different values. But notice I'd still use the 3 and the 4 for both proportions, and that's fine. Okay, one more. And this theorem is probably one of the easier ones. It says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So what that means is, if all of these sides are equal to each other, then so are these sides. And if we want to find x, we can just, if we know that they're congruent, we can take x plus 1 and set it equal to 2x minus 5. And then from there I just solve. Subtract x from both sides. Add 5 to both sides. And that makes x equal 6. Okay, that's all you got to do.